original motivating scenario. And the motivation, of course, was to build a music linked data application, a music platform, which we had discussed in detail in the first chapter and webinar. Then, as you may recall, if you have been following us from the very beginning, we were diving deeper into the data aspect of linked data, namely the SPARQL query language and other means to consume linked data. And in the last webinar, we had talked about how to visualize data, how to prepare it in a way that human users could actually understand it and interact with it. And now we are putting those things together in terms of a full application. That is, in our sketchy architecture, which we had introduced already in the beginning, we're now talking about all of those parts and how they fit together. But in particular, we're talking up here about the application aspects, how to interact with the user, and about that layer which is dubbed linked data dataset around here, because all the data operations are very important still on how to put together a linked data application. Well, before we start to talk about an actual architecture, we could characterize and categorize linked data applications further. We've been talking about linked data and applications all along now, so you have a pretty good intuition already, but you might wonder whether some of those applications are very different from others, or whether there aren't some that are merely claiming to be linked data applications while others are somewhere in between. So a characterization will be the start. Then we talk about general architectural patterns and frameworks that help at building such linked data applications. And in the end, we're taking a closer look at web APIs, which play an important role as a building block. Well, to characterize, apparently, linked data applications are consuming linked data. That's what we've been talking about all along. There are applications that are not doing anything else but just consuming linked data. But in that case, we're typically not talking about a full-fledged linked data application, but rather about a mashup. But in either case, whether it's only consuming linked data or doing that among other things, this is an important criterion. And while linked data can be consumed in plain ways, really reading from a SPARQL endpoint, for example, sending queries to SPARQL endpoint, dereferencing URIs with RDF data, it is also possible that the data out there isn't really available as linked data already. And we still say that an application is consuming it if it is taking other conventional data from the web, using a wrapper to transform them in an ETL-like style, extract it from the original source, transform it into linked data, then consume it. We're still saying that it's consuming linked data in that case. But the other aspect, besides consumption, is the manipulation and production of new linked data. This is what then really makes a full-fledged linked data application. And apparently, to make it a real application, there needs to be some app, typically a web app, because web applications have a number of advantages, but it doesn't have to be web apps necessarily. But for example, if you want to have the linked data application operate on the web at large, which might even be a requirement, for example, in the case of linked open data, then it's certainly a web app, and in many other cases as well. There are different types of linked data applications. In particular, there are two special cases of applications that can be distinguished from all the others. One, there's generic linked data browsers. Linked data browsers are merely consuming existing linked data and are displaying them in a way so that the user can navigate through them. Pretty simple, yet essential. We had talked about that in chapter 4 already. 2, there's linked data search engines. Think about some platform like Google just for linked data, not for web pages. We had also talked about that in chapter 4. And then, save for those 2 special kinds of applications, almost everything else is domain-specific. Domain-specific linked data applications are built for a certain purpose, for a certain application domain to solve a certain problem or a certain set of problems, and are totally targeted to that. This is covering basically everything that you might want to build, unless you're aiming at being the linked data Google or build some of those very fundamental applications. Okay, but also because most of the applications that we might be interested in building, like the music platform, would be domain specific, we might take a look at other more technical aspects that can be used to distinguish different applications, categorize and classify them further. There's semantic technology depth. An application can be extrinsic, in which case it is using linked data technologies on the outside. It's using linked data, APIs, for example, to consume linked data. And it's providing linked data, for example, through a linked data API or through a Spark endpoint and so on. That's on the outside. On the other side, an application might as well be intrinsic, which we use if linked data application, linked data technologies, sorry for that, is being used within the application to represent the inner state of the application. For example, by using a triple store instead of traditional database management systems or other NoSQL techniques. For example, by processing RDF data internally, logically. Of course, an application can be extrinsic and intrinsic at the same time, but only if it is extrinsic, we can also distinguish between the direction of information flow. Extrinsic applications can be consuming linked data. They can only be consuming, then it's a mashup mostly. They can also be producing fresh linked data. And of course, they can do both at the same time. Then there's semantic richness. As we know, linked data have a certain semantics. They are self-identifying, and there are vocabularies that define the meanings of the individual resources. And those vocabularies can be rather non-expressive, rather simple, merely schematic, in which case we're talking about shallow semantics, or they can be much more expressive, as would typically be the case with one of the old profiles as a basic language to phrase the vocabularies and ontology. Then we're talking about strong semantics. And then finally, there's semantic integration. You remember that it's generally considered to be good practice to reuse vocabularies whenever possible. If you do that, and if you do that for all of your application, for everything that you model, then we're talking about a fully integrated application. If you don't do that at all, it's considered isolated because there is no immediate relationship to anything else going on in the linked data world. Of course, there are many shades in between, and in particular, if you would start to build your own vocabulary, but then to publish it so that others could reuse it. That's an edge case because actually by this, following this definition, the application would start off being isolated, but once people are taking up your definition, maybe publishing other data following the same vocabulary, then it would become more and more integrated. An example, a first one would be data.gov.uk, which is basically a governmental data outlet. The UK government and governmental organizations are publishing data, lots of data, thousands of data sets in different formats. Not all of them are really linked data. They are all open data, but much is available in tabular formats such as CSV. Only some portion is really available, identified by linked data standards, such as RDF data. But basically, this is only halfway a linked data application. It's more or less really a download portal with some APIs on top of it. But on top of data.gov.uk, you can build additional linked data applications using that data. And there's also a number of data available on the site. You can check that out and try them out if you like. And data.gov.uk has a twin in the US, which is just data.gov. It's following a very similar idea. It's a totally different platform though. Has even more data sets in it, which fits the respective sizes of the countries. But there is nothing registered in the catalog that is really identified by open standards, by linked data standards, sorry. At least not in the catalog when we checked last time about 2 months ago in July. But also here, you have web apps and mobile apps that you can check out on the site and that are using that kind of data, even though none of that defined as RDF or other linked data. Next example is getting more typical in a way, and not at all typical for linked data application in another way. Dynamic semantic publishing at the BBC. Now, at the BBC, they're aiming at automating the aggregation of related content to articles and other media content that they're publishing on their portal. That started with sports, is now expanding into other departments as well. But think of a sport event, something simple like a football match, say in the Premier League. 2 teams are playing. You have an article about those 2 teams. There are 2 coaches involved that might be mentioned in the article. There is a location, a city where the match took place. A small number of players might be mentioned particularly in the article because they were outstanding. And for all of those, you might offer associated articles, associated topic pages, links to topic pages, where you could check out something like, give me everything about sports events in Greater Manchester. Or I want to read more articles about Man U or Arsenal or whoever was involved. That's what you typically have in all kinds of news companies on their websites. But you can do that manually. You can try to automate it. Now the BBC tried to automate it pretty early on, and they're using semantic technologies to do that. They're using linked data technologies, and quite a bit of that. But they're doing it in a fully transparent way to the end user out there. So if you're just visiting the website, you see that the problem is solved. That they have links to related pages, to related content. You don't see how it is done. And this is why that application at the BBC is a great example for typical industry linked data applications, where an actual problem has been solved using linked data technologies. But it's not so typical in the way that we are often first thinking of applications that are apparently linked data applications, that are exposing the fact of being a linked data application when we talk about it. Also, in the architecture here, they're using a triple store, OLIM, to save all the semantic content that they need to interrelate the article. Journalists see some of what it takes to get that done. They're using a tool called Graffiti to semantically annotate all the articles they're writing. They get some semi-automated support in terms of some suggestions that they could reject or accept, and then they could manually add more annotations. This is pretty similar to tagging, just that it's semantic annotations, and then they're stored in a triple store, which even supports reasoning. And for all the related contents, you can now automatically provide the appropriate links and articles that fit here. So this application is intrinsic. It's not extrinsic. Of course, they're reusing their own linked data, but on the outside, it's not formally extrinsic. It also is somewhere in between in terms of the strength of semantics. As it is not extrinsic, we don't care about the direction of information flow, and it's only partly integrated in terms of being semantically integrated by the definition of that original paper. Third example would be research space. Research space is something totally different with a very interesting approach to the field of cultural historical research. Research space aims to be a one-stop shop to provide and integrate openly available data on that field. They include immense catalogs from important museums, for example, including the British Museum, and all the data they have there on their artifacts in the museum. And it provides a rich interface for the user to interact with that data, to navigate through it, to find some, to discover relations, to display them in various ways. For example, an image might be available in high resolution from the museum, so you can zoom in on certain aspects. There might also be locations related to some artifact, some places where it has been stored before, where it's coming from in case, for example, of archaeological artifacts, the places where it's been excavated. Those can be displayed on a map and so on. Plus, the user has the option to further annotate pictures, to further annotate any artifacts there are, to annotate them with additional relations and properties. And this is pretty expressive because there are many things that turn up if you let someone from the cultural historical research community talk about their interests about such an artifact. For example, they might be not only interested on who painted the picture and when it was painted, they might as well be interested in questions such as what's the subject, or who inspired the picture. Who else did they inspire? They might be interested in the frame that picture is setting in and its historical properties, when it's been built, by whom, and so on. In terms of architecture, it's also using lots of semantic technologies on the inside. If you look at the right-hand side, all down there's a user interface, pretty important. You've seen what it can do. In between, there's a server, and on that server, there's a plugin structure. They have plugins for annotation in particular, image annotation. data annotation. This is building additional semantic data. Then there's an OLIM plugin. Again, OLIM, the triple store with reasoning capabilities. There's also a forum to discuss. Then, on the top right corner, there's the semantic database, the triple store, where all of those annotations can be stored and then evaluated from. So this application is clearly intrinsic and it's also extrinsic. It's both consuming and producing linked data. And it's semantically relatively rich. And there are also other applications building on it. For example, there's a search system, a faceted search. Now, faceted search is when you have your search and can narrow it down according to different criterions. In particular, here, you can search or narrow down by predicates. Anything associated with the objects of your interest, anything there is a predicate, and you can search by any of those predicates, one or several ones. This is one of the beautiful things about linked data technology, because once you have your vocabulary, things like that almost come for free. Next example is the open pharmacology space, and where obviously the open research space did aim to provide a one-stop shop for cultural, historical research. The open pharmacology space does more or less the same for, well, pharmacology. They're integrating several available open data sources and republishing them in a unified linked data fashion. And there are several applications built on that as well, 3 in particular. For once, there's, simple browser. Well, it's not that simple. So this is something which allows you to navigate through all the data available, which is basically that first type of special linked data application that we've been talking about, linked data browsers. But here it's somehow in between, because it is a linked data browser, but it's tailored somewhat towards the specific domain of pharmacology data in terms of additional visualizations and similar things. Then there are advanced visualization components also working on the data. Gem BioNavigator would be one. It serves a single purpose of visualizing molecule structures, but basically any of those, and in several ways, which is far from trivial. And then there's one very intriguing application called PharmaTrack, which does not work on all of the data, but only on those from one original source, one specific original source called Chamble, which is an important open database which is manually curated with many facts about biomedical components. And PharmaTrack provides tools to navigate, browse, visualize that specific content. Architecturally, they're integrating several data sources down here. Some of those are linked data already. Others have to be harvested from the original sources, have to be extracted, then transformed into the appropriate linked data and loaded. That done, they go into an RDF data cache, which is another word for a triple store, a linked data database, where your data are typically being updated on a periodical basis from external sources. And on top of that, they're building a semantic data workflow engine, workflows controlled by the semantics, which gives some of the application logics. And they're having a unified linked data model, and then republish that fully integrated data set in 2 ways. Once through a web service API that, for example, is being used for a control UI that you can use to manage the data, but it's also being published with a SPARQL endpoint. And through the SPARQL endpoint, other applications can hook on again and consume the data as fully linked data. This is obviously intrinsic and extrinsic, consuming data from the outside, publishing it to the outside, but also working with linked data technology on the inside. Direction of data flow, both, as I mentioned. Semantically, it's on different levels, somewhere in between shallow and strong. And it's partly integrated again. And last example is more from the industry kind of motivation side again. eCloud Manager. This is about data center management. If you do have a data center and it's a big one, you have lots of hardware in there. Too much to keep count by hand. You typically use reporting systems from the respective manufacturers to get metadata about which service you have, which machines you have, where they're running, how they're running. You have virtualization capabilities. You have lots of virtual machines and the virtual machine managing hardware and software. You might have software applications and of course license management and related things, and all of those keep their data separately. So you have tons of tools to tell you what's going on and which aspects. And what the eCloud Manager is doing is to integrate all of that into one single semantic view, one overall view that's covering everything from the hardware of various manufacturers to software visualization capabilities and even a business side view. For example, the departments responsible for certain applications or certain hardware, or as well the customers that might be affected if a certain software or hardware goes down, be it for maintenance or due to an error, and the associated project managers that should be alerted so they can get in touch with that respective customers, and so on. And once we have that, it's again possible to narrow down the view and show different kinds of uses, different views of that integrated data, depending on what they're interested in. For example, it is possible to create a view about all the storage infrastructure. Only storage for the responsible department, but no matter from which manufacturer, all integrated. It's possible to do the same for visualization, or on the application level, or on the project level. And from those views, of course, if you need to, you can always browse and navigate further to see what else, even if it's not in your main interest, what else is related to that, what else could be affected by that. With those examples, you have a pretty good idea already of some possible architectural aspects of linked data applications. But to put those patterns in a more general context, first of all, software architecture in general denotes the components, the kinds of components that you use to build your application, and the way how they are connected, how they are interacting with one another. And in general, we are also talking about software architecture not only as a means of building one concrete application of concrete components and a concrete way how to connect them and put them together, but also about general best practices on a more abstract level on how some type of applications can be constructed in general, what kind of general components would be needed in there or could be needed in there, and how you would typically put them together. This is what we're talking about here. And there is one very important architectural pattern which is of high relevance to linked data applications, which is called the multi-tier architecture. This is very popular in web applications in general, also in others, but in particular in web applications. And because many linked data applications use a web app, this is an apparent way to go. The big advantage of multi-tier architecture is that you have a simple, tiered or layered architecture with several components being put in a clear order, one connecting to the other, connecting to the next. No more fancy things. But still, you have clearly separated or somewhat clearly separated layers or tiers where each fulfills a certain purpose. Each could be relatively simply replaced by some other alternative component if you build a new one or if someone else built a better one for the same purpose. Or simply you could as well, of course, take your component and reuse it in different applications with different other layers or tiers, but with one or two of those components of those tiers being reused. And the most prominent example for multi-tier architecture is the three-tier architecture. Traditionally, from bottom to top, you have a data or database layer where you have, well, traditionally, usually a relational database, or in the context of linked data applications, maybe a triple store. Data is being stored there, you can query it, put something in, take something out. On top of that, in the middle sits a logic layer. This is where the business logic is traditionally being implemented. Some business logic is also required in linked data applications. There's some correspondence. And then all on top, the third tier, or first tier if read in the other direction, is a presentation tier. The presentation tier, the user interface is being built. Independently on how the aspects of each individual view in that interface are being calculated by the logic layer. You're just rendering the interface, visualizing it, and making it possible for users to navigate through it, to send requests, to phrase queries maybe in some way, in some visual way. And then, well, the presentation layer, taking the user feedback, sends back to the logic layer, which processes, which sends requests to the database, which sends back some information, which can be further processed, which get visualized again. That's how it typically works. Now, there's one big difference, which makes this last line, this separation between the logic layer and the data layer, less clear on this three-tiered architecture in the case of linked data applications. And that's because traditional relational databases are relatively dumb. You give them some data, you get some data back. Triple stores, however, can implement reasoning to a certain degree. And if you're using reasoning in the triple store, in the semantic database, that is implementing a significant part of your business logic. So there's no clear separation in this case. And whenever your triple store is able to perform such reasoning, and if you want to have any reasoning at all, you will always want to push it down as far as possible into the store, because it's much more efficient there. But in general, that gives us, as a typical basic architecture, a three-tiered architecture still, with a presentation tier where all of that stuff that we have discussed last time in the fourth module can be implemented and applied, with a logic tier in between, though it might not be implementing all of the logic, and with a data tier below, which may implement some of the logic, because the integrated data set in the triple store that we have there might also be the place where some reasoning and therefore some business logic is implemented. But also the data tier here is much more detailed, because there are many things going on. It's not just the database. It's even not just the database plus reasoning. There could be other components, and usually there are. For once, there's the data access. In linked data applications, you're typically consuming linked data. from elsewhere, down here, different sources. And now, no matter how you get them, whether directly through linked data interfaces or whether using wrappers to ETL import data, you have to access it, and maybe you even have to provide things such as wrappers within your data access component to not rely on external components that might all be in here. Then you're typically accessing data from different sources. If you have different sources, they don't always fit together from the very beginning. So you might need to map their vocabulary. That's the case if you have data from different sources using different vocabularies to basically describe the same thing. Then you might also interlink those different data. If there are individuals, entities that describe the same thing, but no one says that they're actually the same, at least not explicitly. And also when using data from different sources, especially if it's data from the web, you might need to clean up corrupted data, poor quality data, and so on. All that together is data integration, and it might happen here in the data layer. So there's a lot more going on than just having a database. And also, as we said, there's often the case that you want to republish some or all of your data. Again, something which happens in the data tier, because there you have the database, from there you can publish. Having that basic architecture, there are different patterns how to access the data. First, there's the crawling pattern. Think of crawling not so much in terms of a web crawler only, but of some tool which may use wrappers, which may use ETL style extraction, which may use any method appropriate to get to the data and transform it to linked data so that it can be stored locally. In the end, you have data loaded into your system, stored locally in your triple store, in your semantic database. And once you have that, you can efficiently work with them, which is the big advantage here. On the other hand, of course, your data might be slightly stale, depending on how often you read all that information from the original data sources. On the other side, second option, on-the-fly dereferencing, on-the-fly loading of all the data that you need. Extremely up-to-date, extremely slow, depending on the number of data sources that you access and so on. And the third option, which is a little more special, is using a federation. Now, in a federation, you do not access a large number of sources, but a very limited number of data sources that you require to provide Sparkle endpoints so that they could answer elaborated queries that you send there. And then internally in your application, you try to phrase all your information needs in terms of a Sparkle query, and then need to find a way to split that query in several queries to send to those different federated Sparkle endpoints so that together you'll get the answer to your whole query, which is far from trivial for once and can also quickly get you into trouble about performance. But with a limited number of external sources, in certain scenarios it can be usable, and in that case it's both providing fresh current data with no crawling stale effect and working somewhat more performant. Way more performant definitely than on-the-fly dereferencing. In the data layer, you can read linked data from a Sparkle endpoint, from RDF, from anything of that sort. You can, however, also, as we now said for a couple of times, rely on conventional data, on legacy data, be it CSV, something tabular like from a relational database, or some other data. And then you would use a wrapper or some other tool to translate it first. To this end, when using several queries, it is suitable to use an architectural pattern which is called mediator wrapper architecture and originally stems from distributed databases. In the mediator wrapper pattern, you have several wrappers accessing several non-uniform data sources and translating them in a uniform way so that the mediator can integrate them all together, put them all together. And once you have decided whether and where you might need such a pattern in several wrappers, the question again on how to really access the original sources, on whether it's in a crawling pattern, on whether it's dereferencing, or maybe in special cases as a federation, that depends on many things. There's the number of data sources that you may need to access. There might be a requirement of consuming very up-to-date data, depending on how current your data must be. You're not free to crawl and maybe have data which is 2 or 3 days stale. Then there's the question how tolerant your system or your users would be with relation to high query running times, long response times, and finally, some of the patterns do not work out at all if you're required to dynamically add ever more data sources. Federation wouldn't work very well under those circumstances, for example. To actually implement a data access component, there's a number of tools available that you can use. There are general mechanisms such as linked data crawlers. There are a few examples given. If you would like to check it out, linked data client libraries, Sparkle client libraries. There are federation engines, of course, and there are APIs all over the web that you can use. For example, semantic search engines or other APIs that provide RDF and related information. And also in the data layer, of course, there's the data integration component. Data integration consolidates the data that you have retrieved from several heterogeneous, non-uniform sources. And this component may operate at 2 different levels, or at both. It can operate on a schema level by mapping vocabularies. It can also operate on instance level by interlinking individuals. Both has been discussed before in chapters 2 and 3 respectively. But then in the end, you'll get your integrated data set. And that is what you would typically store in a local triple store, in a local linked data database. At least unless you're strictly working on a on-the-fly dereferencing scheme, where everything is just used once, displayed to a user, and then thrown away. There's also a wide variety of data stores available by now, some commercial, some openly available. A few examples are given here. Olim, for example, which we have seen in some of the practical examples of linked data applications. There are others, including free ones. And in many cases, you also may want to republish some or all of your data. To do that, again, there's a number of possible techniques. You can provide a Sparkle endpoint, which is pretty flexible and pretty much standard. You can use APIs. There is a project building linked data API best practices that tell you how you should lay out your API to provide standard conform, easy to use linked data. We'll talk a little more about that later in the web API part. You can, of course, simply dump all your data and provide an RDF dump, or you use any built-in means available by your framework or applications that you are reusing, which might be any of the previously mentioned, a combination thereof, or also some other ways. CMS systems such as Drupal and many semantic and linked data application frameworks, such as the Information Workbench and others that we're going to talk about later on, do provide a series of those techniques that are built into the system. And finally, if you have all of that together, there's still the presentation layer and the logic layer. The logic layer is something where the business logic is being implemented, except for those parts that might be delegated to the data layer in terms of direct reasoning on semantic data that you have in your triple store. And then there's all the rest of the business logic. Typically, there can be things like workflows. There can be things like analytical tasks. There can be any other logical things that you need to control or need to build, or that you need to guide your user through the system. It can also include some things like a preparation, some pre-work for the presentation layer, such as an abstract form of giving hints on how to visualize. And in the end, that's the presentation layer, and that's mostly what we had already covered in the last chapter 4. Well, after the break, we're going to talk about the frameworks that can help at building your applications. See you in a few minutes.